The construction sector is one of the largest sectors of the European economy, representing almost 14 million jobs. Although recent decades have seen tremendous progress in improving the energy efficiency of the sector, buildings still consume 40% of Europe's energy demand and emit 36% of total CO2. Besides that, construction and demolition account for 25 to 30% of all waste generated in the EU. Today, most companies in the built environment operate via a linear business model. They have adopted a take-make-dispose system that generates significant amounts of waste. Take sand, for example, and not the kind found in deserts, but the more angular grains found in rivers, lakes, and on the seashore, is the second most consumed natural resource on the planet. It is the main component of both concrete and glass, two materials used to provide a solution to the challenges of urban growth. However, during the construction phase, already 10 to 15% of building materials like sand are wasted. Besides that, an average building is adapted after only 3 years and completely renovated after only 25 years due to changing social, functional, economic, and cultural standards. By doing so, certain materials are demolished way before they've reached their structural end of life. In that way, resources like sand become more and more scarce all around the globe. 54% of the demolished materials are currently being landfilled since they are unsuitable for reuse. They often contain toxic elements and are contaminated with paints, fasteners, adhesives, etc. The rest of these materials are recycled. Concrete granulates, for example, are often used in road construction as a foundation material. However, this practice should be seen as downcycling rather than recycling, since the recycled materials are no longer used in the same way as in the original product. As a result, we'll keep on depleting virgin resources while producing large amounts of waste. A circular built environment offers an alternative approach. Following the principles of cradle to cradle, materials and products can be divided into two cycles. The biological cycle contains organic materials that can safely cycle in and out of the biosphere since they are biodegradable. These materials, for example wood and straw, can be regenerated or regrown. The technical cycle contains the flow of mineral materials that cannot be appropriately returned to the biosphere, such as bricks and metals. Reuse and recycling are key for those materials. In that way, materials can circulate at their highest value and it is possible to design out waste and other negative externalities such as CO2 emission and greenhouse gases. The biological cycle shows the potential of regenerative construction materials. Let's look at the example of straw. Straw is a residual product from agriculture and is available in large quantities. It consists of the stems of grain plants which absorb CO2 during their growth through photosynthesis. When the grain is harvested, the stems are left to dry. Afterwards, they are compressed into bales and used for different applications. Construction is one of them. Since walls made out of straw bales have a lifespan of over 100 years if correctly designed, they can function as carbon storage systems throughout the life cycle of buildings. Straw bales have good thermal and acoustic insulation properties, and while loose straw easily catches fire, compressed straw bales achieve a fire resistance of 19 minutes when they're rendered on both sides. Besides that, the bales are not attractive for mice since they do not feed on straw. Due to the high density of the bales and the renders, buildings aren't penetrable by other small animals either. There are also various options of weatherproofing methods and finishes. The walls made out of straw can be finished with, for example, a lime-based render, but an additional timber boarding or paint coat can be added to change the architectural expression of the building. During the use phase of the building, vapor can pass through the material. This reduces the demand for heating or cooling systems to control indoor temperature and humidity, reducing energy consumption in buildings and providing a healthy indoor environment. At the end of its life cycle, the building can ideally be disassembled following the circular principles. Depending on the lifespan and nature of the materials, they can either be recycled or regenerated. Since straw is biodegradable, its nutrients can return safely to the soil and serve as breeding ground for new materials. And that way, the loop is closed.